All right. It's a good thing I don't get nervous speaking in front of crowds. There's so many of you here today. Like almost 40% of the class is here. So it's kind of weird for me. But today I am going to do what I hope is a huge help to you because what I've been getting in my inbox is a whole lot of folks who don't seem to fully grasp the idea of custom functions, how they work, how to build them, how to think about them. And so I'm going to go back and sort of recap part of assignment 6. I know some of you, this is old hat, but hopefully it'll be useful to you just in terms of thinking and sort of strategizing around custom functions. I should make my text big enough so that actually somebody can see it. That would be probably a smart move if I actually want you to learn anything today. Sorry about that. I forgot because I was doing some actual work on PyCharm and it wasn't really useful for me to not be able to see more than like 4 words on the screen at once. So I made it small again so I could see some code. Anyhow, so I'm going to go back and I'm actually going to do some problem solving out loud live for you with assignment 6, which is the rock, paper, scissors assignment. It's a really good opportunity to learn and think about how to use custom functions in your programs. Now, remember, a custom function is just like or very similar to a native Python function, like the function print that we use all the time, in that it's a command that does something. Now, the custom functions that you will create are commands that do something that you decide, whereas the functions that are built into Python, like print, already have stuff that they do that's sort of set in stone. So, for example, in the rock, paper, scissors program, I created a custom function called computer hand because I know that one of the things that I need that program to do for me is I need it to be able to generate a computer player and their guess, rock, paper, or scissors. So that custom function, computer hand, is a return something function. I know this because it ends in a return statement. The return statement is a magical word when it comes to function because at the point when the program that's running in Python encounters return, it will ignore everything else after it in the code block. In fact, if I try to put something after it, like print hello, what you'll notice is that it gets highlighted by PyCharm for me. And the reason it gets highlighted will tell if I hang out over that with my mouse pointer, it says this code is unreachable, meaning there's no possible way this code is ever getting executed, ever. And that should cause me to think, well, why would that not be executed? Well, the line above it says return. So every time it hits that line that says return, it's going to stop doing anything else after that inside the function, but also it's going to take whatever this is and send it back to the main program. So it's a return function that has 2 lines of code in the code block. The first one creates a private variable. This list exists only inside this function. Remember, what happens in the function stays in the function. So this list contains 3 items, 3 strings, rock, paper, and scissors. The next line is the return line, and it takes a random choice from that list and sends it back. That's all it does. So all it does is every time I run it, it's going to send back rock, paper, or scissors. So if I want to see that in action, I can put that function in the print function. And what that causes is Python will be running down here, running down this page. It hits print, and it says, I'm going to print something. That's the Python function. It's going to print whatever this is. And it says, well, what is that? oh, that's a function, I'm going to go up and look at the definition of that function and figure out what to do next. So it chooses from the list, it sends back one of those strings, rock, paper, or scissors, and then that becomes the thing that it prints out. Now notice if I don't have that and I try and run this, it doesn't do anything. Despite the fact that I have all these lines of code in here, it doesn't do anything because all I've done in this program so far is I've imported the random module. I have defined two variables, two integers that are equal to 0, and I've created some functions. None of that produces anything visible on screen. So if I wanted to actually show me something on screen, I have to do something that causes it to show me something on screen. So I'll print the computer hand. And now when I run that, you can see it pops up with scissors. And if I keep running that, it will continue to randomly choose from that list. That's all it's doing, is just printing the results of the computer hand function. So how would I think about the rock, paper, scissors problem? When I think about a complex program like this, and I decide, hey, I'm going to use functions to make this a better program, I want to think about what are the parts, what are the things that it needs to do, what are the jobs that it needs to do, and how can I break those down into reasonably sized pieces. Now, a few of you in this class read the instructions and said, you need to make a rock, paper, scissors game that uses functions. So what you did is you created a function and you put the whole game inside the function, and then the very last line of your program was just executing the function. And while that is technically using functions to create a rock, paper, scissors game, it doesn't really help much because it doesn't accomplish some of the things that functions are really good for. And so when we start thinking about using functions, we want to think about how can I, what's the job, what's the program, what's my whole plan look like? And how can I break it down into pieces where each one of those pieces could be its own standalone program, like the computer saying rock, paper, scissors is a good standalone program. The player, the human player, also needs to say rock, paper, scissors. So that might be another place where we have a function that does that thing. Now, I want to make sure that the human player can decide rock, paper, or scissors. I also want to make sure that they can't say anything that's not rock, paper, or scissors. And I also want to make sure that whatever they say, rock, paper, or scissors, that it exactly matches one of these things so that I can then later compare them and decide which one won. So let's take a look at this player hand function. So I'm going to define player hand, and I don't need any parameters. I'm just going to execute that. And the one thing I'm going to do when I start this, and I don't always do this, but sometimes it's worthwhile, since I'm collecting input from the user and I want to make sure that whatever I get matches the kind of input that I need, I'm going to put this in a loop. I'm going to put a loop inside this function that says try again, try again, try again until the user puts the right information into the computer, something that it understands to be rock, paper, or scissors. So I'm going to start out with while true. And then I'm going to ask the user for input. And so the prompt that I'm going to give the user is enter rock, paper, scissors. That's a good question. Any guesses on that? Why I have the parentheses? Yeah. because when you're putting in parentheses, you're basically telling the user, hey, don't type out the whole word, just type in this character. So if they wanted to say rock, they would type in R for the computer to receive it. Okay, so yeah, that's correct. That's what I'm doing here. I'm actually going to give the user the option. So I'm going to give them the option to input R or the word rock. But I want to make sure that I control for capitalization because it's a common thing. People accidentally capitalize things and then it doesn't match. So I'm going to take this string. I know it's a string, so I can do what I want to it. And I'm going to set it to all lowercase by putting the lower string method at the end. So it's going to get that input and immediately turn it into lowercase. Okay? Immediately turn it into lowercase. Then I'm going to see what they entered. Okay, so if str input equals R or str input equals rock, then return rock. Okay, so now if they enter R or if they enter rock, it's always going to be lowercase because I just made it lowercase. Then it's going to send back rock, which matches exactly. So I want to do the same thing for the others. Elif str input equals paper or str input equals the whole word paper, return paper. Now, I could put else here, but I'm going to put another elif. Yes, sir. I could do that by stacking. That's a good question. I could stack a strip right on top of that lower. I don't know if I told you could do that or not, but with these string methods, you can stack them. So it'll turn it to lowercase and then it'll strip the white space all in one line. Super cool thing that you can do well, super cool might be overstating it a bit. I think it's pretty cool compared to other programming languages where I might have to like pass it through multiple functions or do some fancy stuff. I can just boom, 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 just put it all right there. So yeah, I guess it is super cool, but only if you're a nerd, which applies to me, of course. Equals scissors or str input equals, of course, the whole word scissors. Can't imagine anybody wanting to type that out, but if they choose to, that's on them. Scissors. Okay, so I've got if, elif, elif. I could leave it here, and it would just keep asking them over and over and over till they got it right. But it's nice to give the user a little bit of feedback. Else, so if they don't put in one of those 6 things, R, rock, P, paper, S, scissors, then I'm just going to print invalid input, try again. Okay, so there's that. And that is the player hand. Okay, yes. /n is a new line character. So I'm just building it in so it hits, it's like hitting enter a couple extra times. It creates some vertical white space. Yeah. So this is going to keep asking them, and we can test this out, right? I can just call that function all by itself. But let's print it so it'll print out the results. So when I run that, rock, paper, scissors, let's test the bad condition. Okay, so that's why it's got some space in between things. It's just a little easier to read. And if I put in R for rock, then it returns rock, just like magic. Okay, so there I have the whole thing. And I can, once I finish doing these functions, this is what I really like to do. If you know you've got a good function if you can do this. If you can just close it up and just know that it works. Like I'm going to call this, it's going to ask the user and it's going to return rock, paper, or scissors no matter what. Computer hand, always going to return rock, paper, scissors no matter what. So I don't even need to think about what those do. I just know. I don't know how to need to know how they work. And no, neither does anybody else really. So the next thing is deciding who won, right? And str player and str comp, I'm going to actually use a string that represents the player's guess and a string that represents the computer's guess. Well, guess where I'm going to get those? These two functions. I can pass them straight through. But let's define this first. So how do we figure out who won at rock, paper, scissors? So the first thing that's nice to do is to reflect back who guessed what. So let's print you guessed what am I doing here? You guessed str player, print the computer guessed str comp, and then we'll throw another new line there. Okay, so now how many different combinations? If the player can guess 3 different things and the computer can guess 3 different things, how many different combinations are possible here? How many? 9. 3 times 3, right? So, however, there are 3 of those 9 conditions that have the same outcome, which are if they guess the same thing. And I can test for those with a single block of code. I can hit all 3 of those. And basically it looks like this: if str player equals str comp, and I've controlled the input so that I know if I put rock, it's always going to be the same rock that the computer chooses if it's the same. So I'm going to print it was a tie. That's the feedback to the user. Got to get my parenthesis up there. There we go. That's the feedback to the user. And now I want to return something. And I'm just going to return the string T for a tie. If it wasn't this, then it's going to go into an else condition. It was either a tie or it wasn't. So if it wasn't a tie, then I need to investigate further and say, well, what was it? Now this is where I find it really helpful to stick to a pattern. And since the game is called rock, paper, scissors, you'll notice up here in player hand, I did it in that order, rock, paper, scissors. If I always do things in that order, it keeps things simpler for my little tiny brain, and that helps me. So if str player equals rock, and it's not a tie, then I have paper and scissors to account for on the computer's end. So I'm going to put inside that, if str computer equals paper, then the computer wins, right? Print the computer won. and return, I'm just going to return a P or a C, depending on if the player or computer won. Okay, so if it wasn't a tie and the computer didn't enter paper, then that means the computer had to have entered scissors, which means print you won and return P for player. Okay, now if you're looking at this and you're going, okay, now you've just got to repeat that 2 more times and switch things around. You're right. So I'm just going to copy that block of code and I'm going to paste it. I could maybe simplify this a little bit with some other functions or something, but I'm not going to. I'm just going to do this as is. There's 1 time and there's 2 times. So now I'm going to substitute. Okay, so we got str player rock up here, paper here. If the computer guessed scissors, then the computer won, right? Because scissors beats paper, and otherwise I won. And then if I guess scissors and the computer guesses rock, then the computer wins, otherwise I win. And just like that, I have the whole who won defined. And all I need to know is that I give it a player string and a computer string, and that's it. So watch this. We can play a whole round of the game now by just typing 1 line of code. That's a whole round of the game right here. Because I'm printing the result of who won. It'll spit out a P, a C, or a T, depending on who won. So it calls this and it says, oh, you need a player string. Let's get that player string from here. Then it goes into the player hand, does all of that stuff, comes back with the return value, rock, paper, scissors, puts it there. It says, oh, I need a computer hand. Goes out to that function, does what it needs to do, spits back rock, paper, scissors, puts it here, and then it can execute who won, compare those two, and return the answer, which is a full round of the game. Let's test it. Rock, paper, scissors. Again, it's still working the same way. If I put in invalid input, then it won't work. But as soon as I do, it says you guessed paper, computer guessed rock, you won. And there's the return, because I did have it print that. So now, all I need to do is one more function. I've already done this one because it's pretty simple. It's just report score. I'm just making it easy to report out the score. But it says the computer score, the current score is, oops, I lost a line there. That's okay. It's easy. Int player score. Okay, so that gives us the current score every time I hit report score. And that score is based on these globals here. Notice I didn't use the global keyword. I can still read global variables from within the function. I just can't change global variables from within the function. So I can still check on those or use those to write something in the function. Okay, so let's set up the game loop. While true, just like always, true. And then the first thing we want to do is have it pull the winner. Okay. Same thing it did before, except instead of printing out P, C, or T, it just puts it in this variable. So now I can, that's 1 round of the game right there. So now I have the winner. All I have to do is increment the score. So if str winner equals C, Then int comp score plus equals 1. We're incrementing the score by 1. Elif str winner equals p. Int player score plus equals 1. Okay, so if it comes back the player won that round, their score goes up by 1. If the computer won that round, the computer scores. If it's a tie, it doesn't do anything because it doesn't need to. That's why I'm using if and elif instead of if and else. We don't want the player to get credit for a game they didn't win. Okay, so next thing we need to do is we need to report the score. Report score, done. Last thing we need to do is see if somebody has won best 2 out of 3 games. So what we're going to do is check the score. If int comp score is greater than 2, print the computer has won. Elif int player score is greater than 2, print the human has won. Okay, and that's really it. Okay, so let's run this. Rock, paper, scissors. If I enter something else, it doesn't do anything. If I enter rock, okay, let's reveal the whole screen because I'm using, what do I do with that? Run. There we go. Okay, so I guessed rock, computer guessed scissors, you won. Current score is me 1, computer 0. I'm just going to keep guessing rock forever. Computer wins the next one. Computer wins again. It was a tie. I won. Oh, it's tied at 2. And the computer has won. Oh, I forgot one thing. Silly me. I forgot to break, right? The human has won. So each one of these should have a break in here. So the game stops when you're done. Now, if I wanted it to ask, do you want to play again? I would just take all of this right here and put it inside another while loop so that after it finishes the 3 games, then it asks you yes or no, and then you can break that while loop if you're done. So that is a little bit deeper look at A6 with functions. I'll put this video online so that you can review it if you need to, but hopefully that was helpful to you.